Before you assign tolerances to your foam and rubber parts, let's talk about how these thick materials react to being cut. In this video, we will discuss why it can be difficult to have precise measurements for thick foam and rubber parts. One of the biggest issues with cutting thick materials is the cutting compression. This occurs when a blade squishes the material during the cutting process, resulting in an oddly shaped concave edge. This phenomenon commonly occurs in both thick and soft materials, like low-density foams and low-durometer rubbers, where the material folds or bends while it is being cut and leads to deformed edges. Other factors that can affect your tolerances, besides cutting compression, is cutting on a rotary die press. In the rotary die cutting process, the blade enters and leaves the material at different times, which can cause angled or slanted edges. This is further exacerbated by the material's tendency to compress, leading to various types of deformation that can make it hard to maintain tight tolerances. Engineers can help avoid tolerance issues by recommending substitute materials. If there's a different material that meets your needs but won't be subject to cutting compression, converters can help you figure out what will work best for you. Engineers will also recommend opening the tolerances, proposing tolerance adjustments that are more realistic given the material properties. This can be a great way to get your part to run on a rotary press with your chosen material. Lastly, engineers may suggest changing the cutting process, opting for a different process such as flatbed die cutting or laser cutting, which can better manage the material's properties and reduce the deformation. Flatbed can be great for thick foams and rubbers. This process reduces the chances of edge deformity because the material stops before the cut. Stationary material produces more consistent cuts as opposed to rotary where the material is moving under the die. However, flatbed die cutting is slower and less time efficient. On the other hand, laser die cutting offers high precision and is suitable for applications requiring tight tolerances. While laser cutting can potentially burn the edges of the material, careful adjustments to the laser settings can minimize this issue. It's important to note that laser die cutting is also slower than rotary, which can increase production costs. But it does provide superior precision for intricate designs. Now that you're aware of the potential issues of cutting thick materials with tight tolerances, it's important to talk to your converter who can guide you to the right decision for your part. If you have any questions, feel free to visit the Learning Center or reach out to us directly. Thanks for watching!